Hi, in this lesson, we need to tackle the field relationships study task. So you'll need the handout with this title on it. You'll also need a ruler and some colouring pencils. Okay, let's go. Now this task is based around this diagram of a small cliff face. We start the task by looking at a few bits of structural geology, marking on the axial plane of at least one fold, and completing the blank part of the diagram here from the descriptions that are there. Axial planes of folds join together the bends within a bed, what we call the hinge points. The fault that's described is formed by compression, and perhaps we should recognise what a dike would look like. If you're not sure about these, don't worry about it. Okay. The main part of this task, though, is to apply some of the relative dating techniques that we've been learning. Looking at what the law of superposition is, and also what we mean by included fragments. Key part of this task, then, is to sort out the age of these beds. Okay. That's what you need to do. Have a go at that now. See what you can come up with. Okay then, let's look at some answers. The first question then, I ask you to draw on the axial plane of a fold. A fairly straightforward task because we look for hinge points. We look for where there's a bend in the bed. So we've got an axial plane there and another one there. Either of those will get you the mark. Notice I haven't labelled these up though. We'll come back to that later. I then ask you to draw in a few more geological details. First of all, a reverse fault with a displacement of 1 metre. Let me draw it in first. So we've got a fault, which is a break in the rock. That's moved all the beds, so the most obvious one perhaps is the lava flow, by 1 metre. Notice that the bed on the south side here has moved up. Now we describe that, that block on the south side as the hanging wall of a fault, because it's the block above the fault. In this case, in what we call a reverse fault, this has moved up. The footwall of the fault, the one to the north or below the fault there, has moved down. Okay, if we measure the distance between the boundary between the sandstone and the lava flow, it's moved by 1 metre. I also ask you then to draw on a dike which can be seen to be older than the fault. So if it's older than the fault, then it clearly must have been displaced by the fault by the same amount. So the red stripe here marks where the dike would be. If the dike was younger than the fault, it would just cut through it and not be displaced. Okay. Let's get into the relative dating here, which is the real key point of this activity. First, you're asked to state the law of superposition. Simply, the rocks at the bottom of the sequence are the oldest ones in that sequence if the rocks are the right way up. Younger rocks get laid down on top of older rocks. I also ask you then to state the law of included fragments. Now, the law of included fragments simply states that clasts in a rock are older than the rock itself. So the clasts are always from a pre-existing rock than the sediment that they're found in, which again makes logical sense. That the class had to exist to be eroded before they could be deposited into another sediment. Now, we're really here leading up to this main question. What's the relative age of the lava flow in the sandstone? Now, you'd expect, through the law of superposition, for the sandstone to be younger than the lava flow because it's above it in the sequence. However, we can see that we've got fragments of lava in that bed of conglomerate. Therefore, the sandstone must be older than the lava flow. This sequence is upside down. And we can tell that because there are included fragments of the lava beneath the lava flow. Now that can't happen. That lava flow had to exist before that conglomerate was laid down. So the conglomerate must be younger than the lava flow, which must be younger than the sandstone. So, if we think about the sequence in which rocks are laid down, if the rocks are the right way up, like in this quite impressive sculpture, the rock at the bottom there must have been put down first. It'd be very difficult to build this the other way around. However, that only applies if the rocks are the right way up. If they're not, then we'll have some other piece of information, a cross-cutting relationship, included fragments, that will allow us to work this out. It's really important for us as geologists to look at all the information we're given, all of that data, and not just immediately jump to the conclusion that superposition always works. Now, we do need to think about how we're going to actually put some proper dates on things, but that's for another lesson. I'll see you then.